So next we discuss about the data flow. So data flow is nothing but how the data is transferred from one point to another. This is called data flow. Here we have classified based on the data flow, we have classified the network into three different kinds. First one, simplex mode. The second one, half duplex mode, and the final one is full duplex mode. So in case of simplex mode, that is the data flow from one direction. Either it may transfer from main, that is server to node. That is the direction of data must be in one direction. That is the simplex mode. In case of half duplex mode, the direction of data is in both the directions. We can transfer the data, but the thing is, once we are transferring the data from source to destination means once it completes, after that only we can transfer the data from destination to source. So that is called half duplex. But in the case of full duplex, we can transfer the data in both the directions in all the times. We no need for wait the transmission completes. So we have to transfer the data in source to destination as well as the destination to source in the same time. So simplex mode. In simplex mode, the communication is unidirectional. That is one direction we can transfer the data. As the example is one-way traffic in our areas. Only one of the two devices on a link can transmit. The other can only receive. So keyboards and traditional monitors are example of simplex devices. The keyboard can only transfer the data and the monitor can only accept the output. That is the example for simplex transmission. Next, half duplex. In the case of half duplex mode, each station can both transmit and receive. We can transfer as well as receive the data in both the directions, but not at the same time. When one device is sending, the other one can receive, and vice versa. The half duplex mode is like a one lane road with traffic allowed in both directions. The half duplex mode is used in cases where there is no need for communication in both directions at the same time. The entire capacity of the channel can be utilized for one or each direction at the time. In the case of full duplex, in full duplex, both stations can transmit and receive simultaneously. You can transfer the data as well as receive the data simultaneously. In full duplex mode, signals going in one direction share the capacity of the link with signals going in the other direction. So, the main example of full duplex communication is telephone network. When two people are communicating by a telephone line, both can talk and listen at the same time. The full duplex mode is used when communication is in both directions is required all the times. The capacity of the channel, however, must be divided between the two directions. This is called full duplex mode. So next we have seen about the network criteria. So the most important of these are first one, performance, reliability and security. Based upon the criteria, we have to find out whether the network is good network or it may be a bad network. So first thing, we must know what is performance. Performance can be measured in many ways, including transit time and response time. What is transit time? Transit time is the amount of time required for a message to travel from one device to another. So that is transfer time or transmit time. So how much of time it takes from a message to reach the destination from the sender. That is called transfer time or transmit time. The response time is the elapsed time between an inquiry and a response. That is called response time. So the performance of a network depends on a number of factors, including the number of users, the types of transmission media, the capability of the connected hardware and the efficiency of the software. So these are all the basic things. Based on these one, the network performance varies. The performance is often evaluated by two networking matrices. First one throughput and the next one delay. So throughput is the output, delay is the time taken between the time gap between the messages. We often need more throughput and less delay. That is, in a good network, it gives more throughput and it gives less delay. However, these two criteria are often contradictory, right? Because once the throughput is increased, automatically the delay is decreased. Then the next one, reliability. In addition to accuracy of delivery, a network reliability is measured by the frequency of failures. Once the network fails frequently, means it's a bad network. We won't select that network for some cluster transmission. But in case of network, whether the failures is very less, the frequency of failure is very less, means it's a reliable network. It's called reliable networks. Then security. So once we are transferring the data from source to destination, we must secure the data, because suppose we are sending some secret information, means we have to secure the data from the hackers. So once the network security is high, then the network performance is also high. So network security issues include protecting data from unauthorized access, protecting data from damage and development, and implementing policies and procedures for recovery from breaches and data losses. This is called security. Then the physical structure. Based on the physical structure, the types of connection is classified to two categories. First one, point-to-point connection. Then second one is multi-point connection. So some nodes are connected through a link. Station 1 and station 2 is connected by using one link, that is called point-to-point, because the particular link is used only for transferring the data from station 1 to station 2. In some cases, in the server connects more devices by using a single cable, that is a single link. So that types of connection is called multi-point. In a multi-point connection provides a dedicated line between, in a point-to-point connection, it provides a dedicated line between two devices. That dedicated line is only used for transferring data from the particular source 1 and the destination. The entire capacity of the link is reserved for transmission between those two devices. Most point-to-point connections use an actual length of wire or cable to connect the two ends, but other options such as microwave or satellite links are also possible. When you change television channels by infrared remote control, you are establishing a point-to-point connection between the remote control and the TV control systems. In the case of multi-point, a connection is one in which more than two specific devices share a single link. There is no dedicated link. There is a link. It has to be shared by more than one devices. In a multi-point environment, the capacity of the channel is shared either spatially or temporally. If several devices can use the link simultaneously, it is a spatially shared connection. If users must take turns, it is a time shared connection. So now we must know the difference between internet as well as intranet. So we know what is internet. So it's a global network, or it's called a public network. Then what is intranet? So intranet is also a type of network, but it's called local network, or it's called a private network. Suppose a company, that's the main office in the head office in Chennai and the branch office in Coimbatore or Bangalore. So it uses one network. That company uses one network to transfer the data between that branches. So that type of network is called intranet. That's not intranet, it's called intranet. It's a private network. Yep.